There is a question almost everyone has heard at some point. If a tree falls in a forest and no one is there to hear it, does it make a sound? At first, it feels like a joke, a philosophical riddle, something clever, but harmless. But buried inside that question is a much deeper assumption, one that quietly shapes how many people think reality works. The assumption is this, that existence depends on being noticed, that without an observer, nothing truly happens. And for a long time, this idea sat comfortably inside philosophy. Then quantum physics arrived and made the question far more precise and far more dangerous. Because quantum mechanics does not ask whether sound exists without hearing. It asks whether physical properties exist without interaction. And that's a very different thing. So let's slow down and be careful here. The original falling tree question is about perception. Sound, after all, is vibration interpreted by ears and brains. If no ears are present, then no experience of sound occurs. That much is uncontroversial. But the modern confusion begins when that question is quietly rewritten as something else. Does the tree itself exist if no one is there? Does the event happen without awareness? And this is where the observer problem enters. Quantum mechanics showed us that at very small scales, particles do not behave like tiny objects with fixed properties. Instead, they are described by probabilities, wave functions, that encode possible outcomes. Only when a system interacts does a particular outcome occur. This was deeply unsettling. Early interpretations sometimes used language that suggested consciousness was doing the collapsing. That observation, by a mind, was required. But this is where many people misunderstand what physics is actually saying. Quantum mechanics does not say that human awareness creates reality. It says that interaction matters. A particle does not need a person watching it. It needs an environment to interact with. A detector, a photon, a molecule of air, something physical. This distinction is crucial. Physicists like Niels Bohr emphasized that quantum properties are not independent things waiting to be revealed. They arise through interaction. But interaction is not the same as consciousness. The universe was interacting long before minds appeared. Stars formed. Galaxies collided. Atoms bonded. All without witnesses. So does reality exist without us? Yes, but not in the classical way we imagine. In quantum theory, reality is not a collection of objects carrying fixed attributes through time. It is a web of processes. Things become definite through relationships. This is where the double-slit experiment becomes relevant, not as a mystery trick, but as a lesson. When particles pass through the slits, they behave like waves. When they interact with a measuring device, they behave like particles. Not because someone looked, but because the system changed. The environment matters. This leads us to a subtle but important shift. The universe does not wait for awareness to exist. But it does not exist independently of interaction either. Reality is relational. And this reframes the falling tree entirely. If a tree falls in the forest, it interacts with the ground, with air molecules, with the surrounding environment. Those interactions are enough. The event is real. The sound waves propagate whether or not a human ear is present. They dissipate into heat. They alter the environment. Nothing needs to collapse for that to happen. The confusion comes from importing human experience into physics. Now let's push further. If interaction is what matters, then what about things we never observe? Events that leave no record we can access. Do they still belong to reality? Modern physics suggests they do, but not always in the way common sense expects. Some interpretations propose that all possibilities continue to exist, branching into different outcomes. Others propose that spontaneous collapses occur objectively, without observers. Physicists such as Roger Penrose have explored models where collapse is a physical process, tied to gravity, not awareness. Meanwhile, decoherence theory shows that interaction with the environment rapidly suppresses quantum interference, making the world appear classical. Again, no consciousness required. This is where the anthropocentric view of reality quietly dissolves. The universe does not need us to run, but, and this matters, our participation still changes how reality unfolds for us. Not because we control it, but because we are part of it. Every observation is an interaction. Every measurement is a coupling. When we look, listen, measure, or record, we are not creating reality. We are joining a process already underway. This has profound implications. It means that reality is neither purely objective in the old classical sense, nor dependent on human minds in a mystical one. It is interaction dependent. This aligns with relational approaches in physics, including work by Carlo Rovelli, who argues that properties exist only relative to other systems. From this perspective, the universe is not a static stage. It is an ongoing conversation of interactions. So let's return to the tree. The better question is not, does it exist without us? The better question is, how does it exist without us? The answer is, as a process unfolding within a web of relationships. And now comes the part that often gets missed. Just because consciousness is not required for existence does not mean consciousness is irrelevant. Awareness does something very specific. It selects, not outcomes, but questions. We choose what to measure, what to record, what to care about, and that choice shapes which aspects of reality become meaningful to us. This is not control over the universe, it is participation within it. In that sense, the observer effect is not about collapsing reality, it is about framing experience. The universe continues whether we watch or not, but what we know depends on where we look. This matters far beyond physics, because many people quietly carry the belief that if they are not seen, they do not matter, that if something is unacknowledged, it is unreal. Quantum physics does not support that belief. Unobserved events are not unreal. They are simply unmeasured. Existence is not a performance. And perhaps that is the most liberating insight of all. Reality does not require your attention to justify itself, but your attention determines what reality means to you. The tree falls either way. The universe unfolds either way. But awareness is where meaning enters, not as a creator, but as a participant.